This problem has to do with Le Chatelier's principle. Whenever we work these types of problems, what we're considering is initially the reaction is at equilibrium. And then we're going to disturb the reaction in some way. And to answer the question, we want to say, in which direction will the reaction shift, or in which direction will the reaction run in order to get back to equilibrium? So the reaction that we're going to look at in this example is solid carbon plus H2 gas to form methane. All right, so in the first example, we add more solid carbon to the reaction mixture. But for this one, remember that the equilibrium constant expression just includes gases and things that are aqueous. So the equilibrium constant for this is just CH4, or the concentration of H2 squared. So adding more solid isn't going to affect the equilibrium. So for this first one, the reaction will be unchanged. All right, in the second one, we're adding more H2 to the mixture. So remember, the reaction was at equilibrium. If I add more reactants, then the reaction is going to have to shift to the right or run to the right to use up those reactants and make more products. So if I add more reactants, the reaction has to run to the right to get back to equilibrium. All right, the next question asks if I remove methane from the reaction mixture. So remember, I was at equilibrium. I then take away product. So I don't have enough products to be at equilibrium. So again, the reaction is going to have to shift to the right in order to get back to equilibrium. The next question asks about what happens when I raise the temperature. So in order to answer that, I need to know whether the reaction is exothermic or endothermic. And so they told me in the question that it's an exothermic reaction. In the case of exothermic reactions, I can think of heat as being a product. So I'm going to write plus heat here. Right, if it was an endothermic reaction, then I have to add heat to the reaction to get it to go. So for an endothermic the heat would be written as a reactant. In the case of this problem, where it's an exothermic reaction, heat is written as a product. And so now, when we think about changing the temperature, an increase in the temperature, that's going to be just like adding heat to the reaction. So that's going to have the same effect as if I'd added product. And so in that case, if I add product, I have too many products, the reaction is going to have to run to the left to get back to equilibrium. So in this case, the reaction will run to the left. All right, then ask what happens if I decrease the volume of the reaction mixture. When I decrease the volume, I'm increasing the pressure. And so to relieve the strain on the system, the reaction is going to shift to the side that has the least moles of gas. So in this problem, I have 2 moles of gas on the reactant side versus just 1 mole of gas on the product side. So in this case, decreasing the volume or increasing the pressure is going to shift the reaction to the right, the side that has the least moles of gas. All right, finally, the question asks, what happens if I add neon gas to the reaction mixture? So that is, of course, going to increase the pressure inside the container, but the partial pressures of our reactants and products are going to remain unchanged. So adding an inert gas has no change on the equilibrium process.